Hi friends, let us start with the INSP Genius for JEE, that is IIT JEE 2020. I am Abhishek Tiwari, going to take your today's lecture, that is Kinematic Dimension 1. So before that, please like and subscribe for the early updates. Thank you. Now, Kinematic Dimension 1. In this lecture, we are going to take only the one dimension studies that covers the motion in one dimension. As you can see, a car is moving in a particular direction. What does it mean? It means that it is moving in either in x direction, in y direction, or in z direction. So the object is moving any of the particular axis. Under this, that is a motion in a straight line, we are going to cover some topics like distance, displacement, speed, velocity, acceleration. We are already being very well versed about these terms, but this is a crash course, so we have to learn each and every terms again. What is the distance and displacement? So what is the distance actually? Distance is what? Is a total path covered. When an object is covering a path, and what we measure is the total distance. And what is the displacement? Displacement is the shortest distance between any two points. So if it is the initial point, that is A, an object is although moving to any path to point P, then what is the path covered? What is the path covered? We can see that the path covered is this. So we measure from A to B what is the total length of the path. This is the distance. And what about the displacement? If we have to calculate the displacement के लिए हम क्या करेंगे? As we know from the definition, it is the shortest distance between any two points. So initial or final position. So we make straight line from A to B, and this is the length, is the displacement. We can say the shortest distance between two points is the displacement. So I think it is very much clear about the distance and the displacement. So let us take an example to understand about the distance and displacement. A person is standing at a point A. As you can see, a person is standing at a point A and is moving to point B. Reaching at point B, the distance covered is 100 meter. And if a person is again moved from B to C, he has to cover 40 meters. Then the total distance means during the journey is 100 plus 40, that is 140 meters. So this is the total distance. And what about the displacement? If we are talking about the displacement, what is the displacement? The displacement is from C to A. The final position here is, this is the final and this is the initial. So initial and final position, we get the displacement as 60 meters. So in this case, we have seen that the distance and the displacement both have the different magnitudes. One has a 140 meter, although he is moving from A to B, B to C. But on reaching at the point C, what will be the displacement? Yes, the final minus initial, we got the 60 meters. This is the displacement. So from this very short example, we have seen the difference between the distance and displacement. As you can see in this problem, that the initial position and the final position are given. So initial and final positions means we have to find the displacement. On the scale, if we see, the object is moving from initial to the final position. So what is the initial position in the first data? It is given that it is at 1 position and moving to the final position as 4. So this is the initial and this is the final position. So here we can calculate as delta x equals to positive 4 minus of positive 1, that is equal to positive 3. What does it mean? It means that the displacement is positive. Now coming to the second, in second case we have seen that object initially at minus 2 and reaching to the point 3. So it is at minus 2 means at this point and reaching to the point 3. So what is the displacement in this case? Yes, the displacement is final minus initial, that is plus 3 minus to the minus 2, that will comes to be plus 5. Again the displacement is positive. Now again if we take the third case, in third case you can see it is at minus 3 and reaches to minus 1. What will the displacement in this case? Displacement is again we will minus 1 to the minus of minus 3, which comes to be plus 2. तो यहाँ भी हमने देखा कि डिस्प्लेसमेंट क्या है, पॉजिटिव है, as it is a one of the point of the displacement that we can measure the displacement as 0, positive and negative. Let us take for the fourth example. Fourth example हम देखते हैं फिर से कि इसमें क्या वो कहता है. Final minus initial. The final position in this case is 1. This is the 1 and the initial position it is 4. So final minus initial यानी कि 1 minus of 4, that comes to be minus 3. यहाँ पे हमारा आंसर जो आ रहा है minus 3 आ रहा है, means that the displacement is negative. Here the displacement is a vector quantity, that's why we are noting it is a positive negative directions. I think it is very much clear about the displacement, how to calculate the displacement. So distance and displacement both are used to measure the path, but in distance we measure the path covered and in displacement we measure the shortest distance between initial and final positions. So it is very much clear from the definitions that the distance is the total path traveled by an object and the displacement is the shortest distance between the final and the initial position. So this is the difference which we see from the definition. Now again the distance is the scalar quantity and the displacement is the vector quantity. Here the distance which we measure is 0 or positive and the displacement we measure is the 0, positive and the negative, as we seen in the previous example. It is the path dependent and displacement is the independent of the path. This is also very much clear from the numerical section. Let's take some more examples in our case that our object, in this case a child on a cycle is moving from path A to B and from B to C. And what is the distance total covered in this case? What is the distance covered in this case? Distance covered is the sum of this path. So we can say the distance covered is 5 plus 7, that is equal to 12 km, 12 kilometer. But what is the displacement? Displacement is the final position is C and the initial position is A. If we measure the total distance, that is from A to B, that is the shortest distance from A to B is what? This is 8 kilometer. So the displacement What is the displacement? Yes, the displacement is 8 kilometer. So here both the answers for the distance and displacement are different. As in the case of distance, we measure the path covered. This is the path. And for the displacement, we measure the length for the shortest distance. As in case, it is A to C. This is the displacement. I think it is again clear from this short numerical that how to calculate the distance and displacement. Now let us see one more example for the distance and displacement. Here we can see the distance and displacement can be calculated as in this numerical. A person moves along a circular field of a radius r. It starts from a point A1 and moves in a clockwise direction to a point 3. Calculate the distance covered by a person from 1 to 3, 1 to 2, 1 to 4 and 1 complete revolution, and also calculate the displacement in each case. Let us try for the first, that is A. In this section we find we are going to calculate the distance. 1 to 3 means if it is moving clockwise direction, 1 to 3 means it is the circumference of the circle and it is a half circumference of the circle. तो circumference जो होता है सर्कल का वो कितना होता है? That is 2 pi r and half is the by 2 which is equal to pi r. So pi r is the total distance covered from 1 to 2. In second case 1 to 2 it is a quarter part, so it is again 2 pi r by 4 which is equal to pi r by 2. In third case 1 to 4 we can take like this or like this, but in problem it is very much clear that the object is moving, a person is moving from clockwise direction. So clockwise direction means, or we can say that we add A or B. Quarter, this is a quarter, the same distance and total semi-circular part. So pi r plus pi r by 2 which is equal to 3 pi r by 2. And in the fourth case we can see a one complete revolution. It is very much clear that it is 2 pi r. The total length of the circular path is 2 pi r. Now what is the displacement? Displacement we can calculate. How to calculate the displacement in this case? 1 to 3 it is again, this is r, this is r, so the displacement is, for the first case the displacement is 2r. In second case we have to calculate the initial and the final position. The initial and final position is like this. So you can see this is a right angle triangle of side r and r. So this comes to be, what is the length of this part? The length of this part is under root 2r. So in this case we can say the B is under root 2r. 1 to 4 again you can say we have to calculate this very length. So this is the same under root 2r. Now the last part of this for complete revolution, as the initial and final points both are same. The initial and final points both are same. So what will be the displacement? Yes, final minus initial means it is 0. So initial and final position is same in this case. So we can say that the displacement is 0. So this is the numerical in which we have to calculate again the distance and displacement. And you can see a child walk from his home, that is 50 meter due north and 40 meter due east and 20 meter due south to reach his school. So here the school, you can see the school the person or sorry, child is moving 50 meter north. Let name it as A, this is B, and this is moving to east direction. This is 40 meters, this is 50 meters. Now 20 meter due south, 20 meter due south, this is 20 meters. Now we have to calculate the distance. So what will be the distance? This is, yes, the same. We have to add all the path. North, then B, let it be C, and this is be D. So this is BC plus CD, which comes out to be 50 plus 40 plus 20 equals to 110 meters. This is the distance. Now what will be the displacement? Now we have to calculate the displacement. Displacement, we know it is the shortest distance between the final and initial position. Final position is this, initial position is this, we join this, we get the displacement. But here we use the some trigonometry. Yes, we just make a triangle like this. These are the parallel, so this is 40, this is 20, means this is 20, this is complete 50, so this length is 30. Two sides are 30 and 40, the third side will be 50. By using the Pythagoras theorem, we can find the third side 50. So the displacement here is 50 meters, that is AD. So this is the graphical numerical problem. Graphical means if you have given some graph and you have to find the distance and displacement. So what is the distance and displacement in this case? Let us see what is the problem actually. From velocity time graph, you can see it is a velocity and time graph. Find the distance traveled. Find the distance traveled for 2 seconds. Distance traveled for the 2 seconds. 2 seconds के लिए हमें निकालना है. तो 2 seconds क्या हो गया? Initially this and this point. So बच्चों एक चीज़ का ध्यान रखना कि in the graph you can, for if you have to find the displacement or the distance, then you have to calculate the area under the curve. Here you can see the triangle from OA and B. So area under the curve will be half base into height. Half base is 2 seconds, height is 10 meters. So we just put the magnitude values and we get the answer, that is 10 meter. Now in second case, from 2 to 4 seconds, what will be the distance? Yes, the distance is again the area under the curve. Let us name as A1. Now the A2 is half, base is 2, height is again 2, which is come to be 10 meters. Now have to find the 0 to 4 seconds. 0 to 4 seconds means 0 to 4 seconds. Area A1 and A2 we add for the distance, that is A1 plus A2, which comes to be 10 plus 10, that is equal to 20 meters. So this is the distance traveled from 0 to 4 seconds. What will be the displacement? Now what will be the displacement from 0 to 4 seconds? What will be displacement? Displacement is what? Yes, displacement we have to calculate as जो भी एरिया ऊपर की तरफ होगा x एक्सिस के, that is considered as a positive, and the area which is below to the x-axis, that is considered as a negative. So we just sum up the areas but putting the negative sign for below the x-axis. So the displacement what will be the displacement? Displacement will be again area A1 plus A2, but here we are going to put the magnitude and the direction. So 10 plus of minus 10. 10 minus 10, why minus 10? Because the area is in negative direction. So answer is 0. The displacement is 0 for the 0 to 4 seconds.